If your AI agent can see secrets, it can leak secrets, not because it is evil, because the system was designed without enough boundaries. Production agents need secret, safe architecture from day one. Here is a dangerous pattern with AI agents. A team builds an agent that helps with internal work. It can read documents. It can summarize tickets. It can search a knowledge base. It can call a few tools. It can write messages. At first, everything looks useful. Then someone asks a normal question. The agent includes too much context in the answer. Maybe it exposes an internal URL. Maybe it includes a customer name that did not belong in the response. Maybe it repeats a private policy exception. Maybe it quotes from a document the user should not have access to. Maybe it includes a token, a credential, or a scanner detail that should never leave the system. Nobody meant for that to happen, but the agent had access. The prompt did not clearly block it. The retrieval layer did not filter it. The output layer did not redact it. The logs stored it again, and now the leak exists in more than one place. That is what this video is about, not scary theory. Practical controls for keeping AI agents from leaking secrets. The first step is defining what a secret actually is. Most people think about API keys, passwords, tokens, and private keys. Those absolutely count, but for AI agents, the sensitive surface is much bigger. Secrets can include customer data, internal documents, private Slack messages, unreleased product plans, security findings, vulnerability details, asset inventories, policy exceptions, executive notes, vendor contracts, authentication logs, incident timelines. Even tool outputs can become sensitive. If an agent queries a scanner, a ticketing system, or a cloud account, the answer may include data that should not be shown to every user. So do not design leakage protection only around credentials. Design around sensitive context. A production agent needs to know what it can see, what it can store, what it can repeat, and who is allowed to receive it. The strongest leakage control is simple. Do not give the agent unnecessary context. A lot of teams do the opposite. They connect everything, every document, every channel, every ticket, every tool, every database. Then they try to fix the risk with one sentence in the prompt. Do not reveal confidential information. That is not enough. If the agent does not need a secret to complete the task, keep that a secret outside the context window. If it only needs a summary, give it a summary. If it only needs a status field, give it the status field. If it only needs a risk score, give it the risk score. Do not pass the entire raw record when a smaller structured object would work. This is especially important in cybersecurity workflows. A vulnerability TRIAGE agent may need severity, affected system category, evidence status owner, and remediation deadline. It may not need full host names, credentials, internal notes, or sensitive exploitability details in every step. Least privilege applies to context too, not just tools. The next control is separating secret access from reasoning context. Some systems pass secrets directly into the model because it feels convenient. The agent needs to call an API, so the key goes into the prompt. The agent needs to inspect a file, so the full file goes into the conversation. The agent needs to update a ticket, so all ticket fields get dumped into memory. That design is fragile. A safer pattern is this. Keep secrets inside controlled tools and services. Let the agent request an action. Let the tool handle the secret. Return only the minimum result the agent needs. The model should not need to see the API key to use. Why? It should not need to see the database password to request a database lookup. It should not need the full private document. If a filtered answer is enough, think of the agent as the decision layer. Think of secret bearing services as controlled execution layers. The more secrets you move out of the prompt, the fewer secrets the agent can accidentally repeat. Redaction should happen before sensitive data spreads. There are 4 places to watch: prompts, memory, logs, outputs. If sensitive data enters the prompt, it may appear in traces, debugging tools, model, logs, saved conversations, or downstream summaries. If it enters memory, it can reappear later when nobody expects it. If it enters application logs, your logs become a new sensitive data store. If it enters the final response, the leak has already happened. So build redaction into the pipeline. Mask token. remove credentials, drop unnecessary personal data, replace sensitive identifiers with safe labels, use allow lists for what can be included, not just block lists for what should be removed. For example, instead of asking, did we remove every possible secret pattern, ask a safer question. What fields are allowed to reach the model for this task? What fields are allowed to be saved? What fields are allowed to be shown to the user? That is a much stronger design. Tool access is another leakage path. An agent may not leak through text directly. It may leak by sending a message, creating a ticket, posting to a channel, updating a CM, writing a report, uploading a file, calling a webhook. So tool permissions need output boundaries too. Do not only ask which tools the agent can use, to ask where those tools can send data, which channels are allowed, which users are allowed, which systems are internal only, which actions require approval, which fields are blocked from external writes. For sensitive workflows, the agent should often draft first and ask for approval before anything leaves the system. That approval screen should show what will be sent, not a vague summary, the actual outgoing content. If the content includes private data, the reviewer needs to see that before it goes out. Retrieval can create very subtle leaks. The user asks a question. The agent searches a knowledge base. The retrieval system returns private documents. The agent summarizes them. Now the user has information they were never supposed to access. This is not just a prompt problem. It is an access control problem. Your retrieval layer needs permissions. The agent should not retrieve documents for a user unless that user is allowed to access those documents. Document level permissions matter. Source labels matter. Sensitivity tags matter. Freshness matters. Authority matters. Public FAQ, an internal policy, a security exception, and an incident report should not be treated the same way. Before retrieval results reach the model, filter them by the user, the task, and the sensitivity level. Then make the output respect those same boundaries. Private context should not become public just because an agent summarized it. You cannot know if leakage controls work unless you test them, and the tests should include uncomfortable cases. Ask the agent to reveal hidden instructions. Ask it to include raw tool output. Ask it to quote private documents. Ask it to summarize data for the wrong audience. Ask it to write an external message that includes internal details. Ask it to remember something sensitive and repeat it later. The goal is not to trick the model for fun. The goal is to find where your system boundaries fail. Every production agent should have leakage tests, a safe output test, a retrieval permission test, a memory hygiene test, a logging test, a tool write test, a role-based access test. And when a test fails, do not just add another sentence to the prompt. Fix the layer that failed. Context filtering, tool permissioning, redaction, approval gates, retrieval access control, logging rules. The prompt is one control. It should not be the only control. Monitoring is necessary, but monitoring can also create risk. Teams often want full traces so they can debug agent behavior. That makes sense. But if those traces contain prompts, tool responses, user inputs, and final outputs, the monitoring system may now hold sensitive data from every workflow. So logging needs a policy. What gets logged? What gets masked? How long is it retained? Who can access it? Can logs be exported? Are secrets removed before storage? Can sensitive sessions be replayed safely? Good monitoring should help you investigate behavior without turning every trace into a secret dump. For high-risk workflows, store structured events instead of full raw content when possible. Agent requested tool. Tool approved. Sensitive field redacted. External write blocked. Human approval required. That gives you operational visibility without storing everything the agent saw. Let us make this concrete. Imagine a vulnerability triage agent. It reads scanner findings, checks asset criticality, looks at ownership, drafts a ticket update, and recommends remediation priority. That agent may touch sensitive data, internal host names, ASEG, business unit names, exception notes, exploitability context, ticket comments, maybe even customer impact information. A secret, safe design would limit what reaches the model. The agent gets normalized fields, not raw scanner dumps. Credentials never enter the prompt. Sensitive identifiers are masked unless the workflow requires them. Retrieval only returns documents the current user can access. The agent can draft ticket comments, but external updates require approval. Logs record decisions and redactions, not every raw finding. The final response separates public summary from internal details. That is the difference between an agent that is helpful and an agent that is quietly dangerous. Here is the checklist I would use before trusting an AI agent with sensitive data. Define what counts as sensitive in this workflow. 2. Minimize what the agent can see. 3. Keep credentials out of prompts and memory. 4. Use tools to handle secrets instead of exposing secrets to the model. 5. Redact before prompts, memory logs, and outputs. 6. Restrict retrieval by user, task, and document sensitivity. 7. Lock down where tools can send data. 8. Require approval for external or high-impact writes. 9. Test leakage attempts directly. 10. Monitor behavior without storing unnecessary raw secrets. The big idea is simple. Do not depend on the model to keep secrets safe by itself. Build a system where the model sees less, stores less, sends less, and gets checked before sensitive data leaves the boundary. That is how you make AI agents safer in real production workflows. If you want more practical AI agents for cybersecurity and automation, subscribe, and I will see you in the next one.